Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9s. Welcome to today's lesson for natural sciences. We are looking at term 3, and the knowledge area is energy and change. And this section contributes 80 marks towards your final examination, so please pay attention and take advantage of these marks because they're relatively easy to get. The topic for today's lesson is still forces, and this is our last lesson under forces. And the subtopic is electrostatic forces. By now, you should already know that my name is Kwanele Dlamini, and this lesson is proudly brought to you by the Gauteng Department of Education. So let's begin. So what's the point of this lesson? What are we trying to achieve? We are trying to ensure that by the end of this lesson, you should be able to explain that when certain materials are rubbed together, they can acquire an electrostatic charge. You should also be able to explain electrostatic charge in terms of the movement of electrons. You should also be able to describe forces between unlike and like charges. You should also be able to explain that charged objects in an electrostatic system possess potential energy. You should also be able to describe the causes of a lightning strike. And lastly, you should be able to list safety precautions that should be taken during thunder and lightning storms. Now, for more information on this, you can refer to the grade 9 CAPS document on page 72. Let's continue. So now we're going to take a step back and revisit some of the concepts that we've learned in previous grades because they lay a foundation for today's lesson. In grade 5, we learned about energy and movement. But what is energy? Energy is defined as the ability to do work. You need energy in order to be able to do work. But what is movement? Movement is the change in position from point A to point B. Right. So what's the correlation between the two? Energy and movement. Okay. This is kinetic energy. In order for objects to be able to move, they need to have an energy, which is what? Kinetic energy. For kinetic energy to exist, you need to have a certain velocity and the mass of an object. All right. Let's continue. In grade 7 and in grade 8, you learned about gravity and gravitational forces. But what is gravitational forces? This is a force that pulls objects towards the center of the earth or towards another object that has a mass. So mass plays a very important role for these types of forces. Why? Because the larger the mass of the object, the greater the gravitational force. And the shorter the distance between the two objects, the greater the magnitude of the force. But then what happens if the mass is small or if the distance is large? So if the distance between the two objects is large, the magnitude of the gravitational force will be small. And again, if the masses of the objects are small, then the magnitude of the gravitational force will also be small. We also learned about bonds. We said a bond is a force that holds or binds atoms together. It is because of this bond that we are able to form molecules and compounds by binding two or more atoms together. And lastly, we learned that particles and gases have weak forces that are holding them together. Why is that the case? That is because particles and gases are further apart. They are dispersed from each other and they have a higher kinetic energy. As a result, the force that is supposed to bind them together is weakened because they are further apart. Remember, we said the further the objects are apart, the longer the distance between the objects, the lower the magnitude of the force acting on that object. So now that we've covered some of the concepts that are required for this lesson, let's quickly move forward with the baseline assessment, which is nothing but a test of what you understand about the concepts that you either know already or that we are going to learn today. So the first question that I have for you is, what is an electrostatic force? Question 2, what is lightning? Question 3, what is potential energy? And lastly, what force causes the formation of electrostatically charged particles? You have 4 minutes to work on these 4 questions and feel free to discuss with your friend And when you're done, we're going to discuss the answers together. All right, learners, I hope you were able to work on these 4 easy questions just to refresh your memory. Let's quickly discuss the answers together. So without any waste of time, let's begin with question 1. What is an electrostatic force? We define an electrostatic force as a field force that arises through differences in electric charge of objects. It's a field force or a non-contact force that arises through differences in electric charge of objects. Right. So whenever you have objects that have an electric charge, chances are you are going to have an electrostatic force. Number 2, what is lightning? Anyone? What do you think? Yes, that's correct. Lightning is the electrostatic discharge that occurs during a thunderstorm. It's an electrostatic discharge that occurs during a thunderstorm. That is good. What is potential energy? I'm sure everyone knows the answer to this one. What is it? Yes, that's correct. It is energy that is stored in a system. Okay? And lastly, what force causes the formation of electrostatically charged particles? Yes, that is correct. It is friction. Right, let's continue with our lesson. So now we are going to define a couple of terms that we are going to encounter in the lesson so that we don't need to consult a dictionary or Google to find meaning, okay? So let's begin with the first one. The first term that we are going to define is an electrostatic force. What is an electrostatic force? An electrostatic force is a field force or a non-contact force that arises through differences in the electric charge of objects. It's a field force that arises through differences in the electric charge of objects. Okay? The second one is going to be lightning. Lightning is defined as the electrostatic discharge that occurs during a thunderstorm. Electrostatic discharge that occurs during a thunderstorm. The next term that we are going to define is potential energy. What is potential energy? We did these questions. We defined these things in our baseline, but let's redefine them so that we drive understanding home. Potential energy is energy that is stored in a system. Energy that is stored in a system. The next term is to attract. What is to attract? Attract means to make something move towards another thing. Okay? You make something move towards another thing, like that. Okay? And the next one is going to be repel. Repel means to push away from something. You are pushing away from something. Okay, that's to repel. And the last term is an electric discharge. What is an electric discharge? It is the release of electric charge through a solid, liquid, or a gas. It's the electrostate. It is the release of electric charge through a solid, a liquid, or a gas. Let's continue. Electrostatic forces. Interesting. Now, from the shock that you get when you try to touch a doorknob to that little trick that you do with a charged balloon where it ends up pulling your hair, obviously it doesn't work when your hair is as short as mine, but when it's longer, it does work. And of course, to that giant spark of light that we see in the sky during a thunderstorm that rambles and scares everyone. These are all examples of electrostatic forces. But what is the scientific term for this giant spark of light? Yes, that is correct. It is lightning. So, in this lesson, we are going to try and understand how all of these come to be or how they work. We are trying to understand how they work. But what are these? These are electrostatic forces. So let's begin. Right. We know that objects with the same electric charge repel each other. They move further apart from each other, right? And we also know that objects with opposite charges, they attract each other. In other words, they move towards each other. And we can illustrate these as follows. We have the same charges in both instances. The first one is a positive and a positive charge, and they repel each other, right? The second one, we have a negative and a negative charge, and they attract or they repel each other, sorry. So both of these have the same charge or like charges, and they what? Repel each other. But then what happens if the charges are not the same? Well, for opposite charges, they will attract each other, just like male attracts female. But okay, let's continue. Okay. An electrostatic force is a force that two electrostatically charged objects exert on each other over a distance. So it's a force that exists between two electrostatically charged objects that have a charge. Doesn't matter what charge it is. It could be positive for both of them, or it could be negative for both of them, or it could be positive and negative. So whenever you have objects that have those types of charges, chances are they are going to experience an electrostatic force. And it's exerted over a distance. That's why we call it what? A field force. Okay? Or a non-contact force. Electrostatic forces act in an electrostatic field. That's why we call it a field force. But what is a field? It's a region in space where an object will experience a force, right? So if we bring an object closer to this object that is charged, the other object will experience a force in that field. That's the electrostatic field. Okay. An electrostatic field exists around any charged object. So whenever you have an object that has a charge, doesn't matter what charge it is, it could be positive or negative, it's going to have an electrostatic field. Okay? And we know that atoms are made up of smaller subatomic particles. They are electrons, which are negatively charged and spin around the nucleus of the atom, and protons, which are located inside the nucleus of an atom, which carry a positive charge, as well as the neutrons, which are neutral and are located inside the nucleus of an atom. That is going to be a typical example of an area where you're going to find electrostatic forces. Why? Because we have two different charges. The protons carry a positive charge, the electrons carry a negative charge. And we said what? Electrostatic forces arise through differences in electric charges. Okay, let us continue. So inside the nucleus, we have positively charged protons and neutral neutrons. The neutrons don't carry any charge. Okay? The protons and neutrons are held together in the nucleus by very strong forces. So the protons and neutrons are held together by very strong forces inside the nucleus. Okay? If we want to break this, under normal circumstances, they stay in the nucleus, okay? Because the forces that are binding them together, they are very strong. So if we were to try and extract them, we would need a very high amount of energy to do so. But under normal circumstances, we choose not to do so. Atoms are electronically neutral unless electrons are added or removed. So an atom has the same number of protons and electrons. So the overall charge of the atom will be 0. Why? Because the negatives are equal to the positives. Whenever you have a negative number plus a negative number plus a positive of that same number, you are going to get 0 as the overall, right? It's like when you have -2 plus +2, the overall number is going to be 0, right? So that's what makes atoms neutral. It's because they have the same number of protons and the same number of electrons. Okay. So in an electronically neutral atom, the total positive charge in the nucleus is balanced by the total negative charge of the electrons around the nucleus. That's what we just explained. We have the same number of protons, which are positively charged, and the same number of electrons, which are negatively charged, and the overall charge is going to be 0 or neutral. Okay. So if electrons are removed, if we decide to remove electrons, usually by rubbing the substance against another substance, then the atom is no longer going to be neutral. Why? Because we are taking away the negative electrons. We remain with what? The positive protons. So now the overall charge is going to be a positive because we have more protons than electrons. Okay? So this can be illustrated as follows. Imagine this being an atom. The atom has the same number of electrons and protons. They equal each other so that the overall charge is 0. Right. If we take electrons away from this atom, it's going to be what? Positively charged. Why? Because there are more protons than electrons. And it's called what? A cation when it's positively charged. But don't worry about this term. You're going to learn more about it in grade 10, 11, and 12. Right. And then if we add electrons to a neutral atom, this is what is going to happen. We are going to have a negative charge. Why? Because initially we had the same, imagine my hand, this one being the negative charges, being electrons, and this one's being protons, right? If I add more to the left-hand side, if I add more fingers to my left-hand side, then they will outnumber the fingers on the right-hand side, right? Imagine these are positive, these are negative. If I add more fingers to my left hand, then there's going to be more negative fingers than the positive ones, okay? But in this case, it's electrons, okay, not fingers. Right, and they are called what? Anion. But you don't need to know that term for now. You're going to learn more about it in grade 10. Let us continue. So if electrons are added and the atom is no longer neutral, but it becomes what? Negatively charged, because there are now more electrons than protons. So we can illustrate this in this diagram as follows. Initially, we have inside the nucleus, we have 1, 2, 3, 4, 5, 6 protons. We are not going to pay attention to the neutrons for now. And then around the nucleus, we have 1, 2, 3, 4, 5, 6 electrons. So the atom is neutral. Right, imagine we are adding 1, 2 more electrons. What is going to be the overall charge of this atom? We have plus 6 protons. Let's count the number of electrons that we have now. We have 1, 2, 3, 4, 5, 6, 7, 8. Minus 8. What's the overall charge? Minus 2. So now the atom is no longer neutral, but it's what? Negatively charged. Why? Because we have more electrons than the protons. All right. So the electrostatic charge of substances can be changed by rubbing two substances together. Okay, we can change the electrostatic charge in an object by rubbing it against another object. But what force do we use for that? It's friction, okay? So under normal circumstances, the electronic charge is only changed by the movement of electrons. Under normal circumstances, only electrons can be exchanged between objects. We don't exchange protons under normal circumstances. And we do this by rubbing two substances together. And this is because of what we've already mentioned, that protons and neutrons are held together by strong forces or bonds inside the nucleus. Right, now let's talk about a perspex object. A perspex object could be in the form of a cylindrical prism or a glass prism, right? When it's rubbed with a woolen cloth, it releases its electrons, and then it becomes what? Positively charged. But the woolen cloth will take the negative electrons and become negatively charged. So initially, both these substances were neutral, and then we started rubbing them together. Actually, let's show the picture. The perspex object becomes positively charged, and the woolen cloth becomes negatively charged. And this is what happens. This is the process where we are rubbing. The rubbing causes the perspex object to lose its electrons to the woolen cloth. Obviously, this will work best when both these substances are dry. If one of them is wet, it's going to be a problem, right? So we rub the two substances together. The perspex object will lose its electrons and become what? Yes, positively charged. And what's going to happen to the woolen cloth? Yes, it's going to be negatively charged. So this is what they look like after rubbing. They have traded electrons, right? The perspex loses its electrons and remains positively charged, and the dry cloth takes the electrons and becomes what? Negatively charged. Okay. Now, let's do a couple of questions just to test whether we understand what we've done so far. Number one. Okay. But before we continue, I would like to remind you that if you have a question for us or if there's anything you need clarity on, you can send your question through to our WhatsApp line, which is 064-748-8913. That's 064-748-8913. So if an object gains electrons, will it become positive or negatively charged? That's the first question. Question 2, when perspex or glass is wrapped with a woolen cloth, it loses electrons. Does the perspex object become positively charged or negatively charged? You have 2 minutes to work on these two questions, and then when we get back, we're going to discuss them together and do a demonstration for electrostatic forces. So your time begins now. All right, learners, I hope you were able to answer these two very easy questions. So without any waste of time, let's discuss them together. The first question was, if an object gains electrons, will it be positively or negatively charged? What do you think? I'm very interested in knowing your answers. Yes, it is going to be negatively charged. Why? Because when it gains electrons, the overall charge becomes negative. Initially, it's neutral, but if you add electrons, you're making it negative, okay? When a perspex object or glass is wrapped with a woolen cloth, it loses electrons. Does the perspex or glass become positively or negatively charged? Anyone? Yes, that is correct. It becomes positively charged. Why? Because it loses electrons in the process. So now let's quickly do let's take a break and then we will do our demonstration for electrostatic forces.
You are responsible for your own life. You are. You are responsible for the things that are currently happening in your life right now. Nobody is going to push you to become a better student. Nobody is going to push you to read more, to study more. You are responsible to put in the time necessary so that you can get the results that you want in your life. So today, make sure that you are putting in the work. Make sure that you are responsible in doing everything that you want to do. Because for you to achieve more, you need to put a little bit extra work to what you are doing and keep on believing. Keep on believing and keep on doing, and you will see the success that you want.
On what we have learned so far. In my hand, I have a plastic ruler and I have pieces of tissue paper. I want to observe what happens if I charge the ruler in my head and then I bring it closer to the pieces of toilet paper. So I don't know what's going to happen, but we are going to find out together. Okay, so let's begin. I'm going to wrap the ruler in my head. I'm charging it. It's going to take a negative charge from my head. My head is going to be left positively charged. And I bring it close to the pieces of paper. See what happened? This was attracted. Why? Because of electrostatic forces. When I charge the ruler in my head, it gains, when I charged it in my head, it gained electrons from my head. And then when I brought it closer to the pieces of paper, it repelled the negative charges of the pieces of paper and attracted the positive charges on the pieces of paper. And that's why there was this attraction. And what did you observe? This happened over a distance. I didn't have to place it in contact with the pieces of paper. But now let's observe, if I bring the side that is not charged in my head of the ruler, I charged this side, and now I'm going to bring the other side, right? If I bring the side that was not charged closer to the pieces of paper, nothing happens. Why? Because this ruler is neutral and these pieces of paper are neutral, or these pieces of tissue paper are neutral, and hence there's no electrostatic charge. Why? Because we said, remember when we started, we said that an electrostatic force will exist between any charged object. This side was charged, and hence we were able to see this attracting the pieces of tissue paper, but this side was not charged, and that's why nothing happened. Okay, that brings us to the end of this little demonstration. We're going to take a break and go back to our lesson.
You are responsible for your own life. No matter how old you are responsible for the things that are currently happening in your life right now. Nobody is going to push you to become a better student. Nobody is going to push you to read more, to study more. You are responsible to put in the time necessary so that you can get the results that you want in your life. So today, make sure that you are putting in the work. Make sure that you are responsible in doing everything that you want to do. Because for you to achieve more, you need to put a little bit extra work to what you are doing, and keep on believing and keep on doing, and you will see the success that you want.
So before we continue, I would like to remind you of our WhatsApp line, that is 064 748 8913. That's 064 748 8913. If you have a question for us and you have anything that you need clarity on, you can send us a message to that line. That's 064 748 8913. Let's continue with our lesson. Now let's quickly do an activity. Number 1. Complete the following sentences using the words in the block below. This is the block. You have repel, attract, negatively, positively, neutral, gains, and loses. Repel, attract, negatively, positively, neutral, gains, and loses. So 1.1 reads as follows. Two objects with like charges dash each other, whilst two objects with unlike charges dash each other. 1.2. A perspex object becomes dash charged when wrapped with a woolen cloth. 1.3. When plastic is wrapped with a woolen cloth, it dash electrons. So you have, okay, sorry, there's more questions. Number 2, what did you observe when the charged plastic ruler was brought closer to the pieces of tissue paper? And lastly, why do you think the pieces of paper reacted in this way? So you have 3 minutes to work on these 3 easy questions, and when you're done, we're going to discuss the answers together. And your time begins now. All right, learners, let's quickly go through the questions together so that we can move on to an even more interesting topic, which is lightning. Okay, so let's quickly answer the questions together. 1.1, two objects with like charges dash each other, whilst two objects with unlike charges dash each other. So what do you think is the answer to this one? Yes, that is correct. Two objects with like charges will do what? Repel each other, whilst two objects with unlike charges will do what? They will attract each other. Okay, very good. A perspex object becomes dash charged when wrapped with a woolen cloth. So what's the answer to this one? That is correct. It becomes positively charged. You are doing so great so far. Thank you. When plastic is wrapped with a woolen cloth, it dash electrons. When plastic is wrapped with a woolen cloth, it dash electrons. What's the answer to this one? Yes, it gains electrons. Okay. So number 2, what did you observe when the charged plastic ruler was brought closer to the pieces of paper? Yes, that's correct. The pieces of paper were attracted to the ruler. And lastly, why do you think the pieces of paper reacted in this way? Well, that's because of the difference in charge between the ruler and the pieces of paper. When we wrapped the ruler, it gained electrons, whilst the pieces of tissue paper were neutral. And then when we brought it closer to the pieces of paper, it repelled the negative electrons of the pieces of paper and attracted the positive the positive charges of the pieces of paper. And that's why we saw the attraction, the force, causing the force of electrostatic attraction. Okay, let's continue. Now let's talk about lightning. What is lightning? Yes, that's correct. It's that giant spark of light that we see whenever there's a thunderstorm that makes everyone shiver. Okay? So potential energy is energy that is stored in a system. Lightning is a form of potential energy. Okay? Static electricity has potential energy because it can do work. Okay? Lightning is a giant spark of electricity. So that flashing light that you see coming from the sky, maybe striking the ground or within the cloud, is a form of electricity. It's actually a release of static electricity. Okay. The movement of water. So how does this lightning come to be? So there's inside the cloud, there's a movement of water droplets, air in the cloud, okay, and air in the clouds, which creates friction. The friction causes different charges in different parts of the clouds, okay? Whenever this stuff is bumping each other and rubbing against each other, what happens? Charge is formed, okay? When the electrostatic charge becomes high enough, it discharges in the form of lightning, okay? Right, the thunder is a rapid expansion of air as a result of lightning. The thunder, that rumbling sound that scares you whenever there's like a thunderstorm or whatever, a rainfall, is called what? Thunder, that rumbling sound, which is a result of lightning. Okay. The energy in a lightning bolt is very, very high and can cause death. If it strikes you, you are dead. Okay? So you should take safety precautions during a thunderstorm or lightning strike to protect yourself. Okay, so this is basically what it looks like. Okay, you have an accumulation of charges in the cloud which ends up being discharged to either within the cloud or the surface. But don't worry, we're going to explain this further as we continue. Okay. So what you normally see is something like this. You're going to see these giant sparks coming from the sky to the ground or running around the cloud itself. Sometimes it rains and you still see this sparks or lightning strikes. Okay, So now let's try and explain lightning so that everyone will understand how it comes to be. Okay, so this is what happens. You have particles of air and water or moisture in the cloud. Okay, the temperature inside the cloud is very low. Okay, the temperature drops to the freezing point of below the freezing point of water, so that the particles of water that are within the cloud, they are going to freeze. Okay, but there's winds there and there's a lot of motion going on in the cloud, and hence these particles start bumping each other. They rub against each other, and there's upward currents or upward draft, particles moving in all sorts of directions, but there's some that are moving up and then some that are moving low. So the ones that are moving down, they knock off electrons from the ones that are moving up. Okay, so imagine you have pieces of ice that are bumping each other, and the pieces that end up going in the upward direction, they become positively charged, and the pieces that go down in the bottom direction, or downwards, they become negatively charged. So over time, this charge is going to accumulate. At the top of the cloud, you're going to have an accumulation of a positive charge, and at the bottom of the cloud, you're going to have an accumulation of a negative charge. Now, over time, these differences in charge is going to accumulate large enough that it has to be released. Okay, so electrons have a tendency to try to move from a negative place into a positive place. And isn't that what we are trying to do anyway? We are all trying to move from a negative place in life to a positive place in life. So that applies to electrons as well. Okay, so inside the cloud, so the discharge is going to happen between, there are three possible discharges that can occur. So within the cloud itself, or within the cloud and another cloud, there's going to be a release of these electrons. They are going to be attracted to the positive, let's say the negative charges are going to be attracted to the positive charges. And when they are released, when they jump to the other side, there's the spark that is released. Okay, you can see it within the cloud itself, or it can be between the cloud and the ground. But how does that work? Right, the negative charges at the bottom of the cloud, they repel the negative charges at the bottom, at the ground, right? On the Earth's surface, they repel the negative, pushing them down, pulling forward the positive charges of the ground. And then once there's enough charge accumulated there as well, they are going to be released as a spark. So there's three possible things that can happen. It's either the discharge is going to happen within the cloud, or within the cloud or in another cloud, or it's going to happen between the cloud itself and the ground, or some really unlucky person might just find themselves being stricken by this lightning strike. And that's the most unfortunate event that can happen. Right, so I hope this explains the formation of lightning. Let's continue to safety precautions that we should take in order to prevent ourselves from getting harmed by lightning, because it's very, very dangerous. It has a high voltage, and the energy it carries can light up a dark night sky. Okay, you don't want that amount of electricity striking you, because chances of survival are very minimal. Okay, so what can we do to protect ourselves from a lightning strike? We can install a lightning conductor. Lightning conductor is a substance that will draw the lightning to itself instead of like other objects. Okay, or we can seek shelter in a car or a building. Cars are made up of many things that are rubber based, and rubbers don't conduct electricity. So if you take shelter in a car, your chances of being stricken by lightning are very minimal. Or you can take shelter in a building, right? Chances are there is a possibility of getting stricken even if you are in that building, but they are very minimal, because it may strike a section of the building or maybe the structure itself, right? Protecting you, the person who's inside. Right. Another thing that you should avoid at all costs, you must stay away from water. Water tends to have very bad tendencies when it comes to electricity. It tends to conduct. And that's why when you try to touch a socket plug or a plug at home with wet hands, yes, you know what happens. You get that electric shock. Okay? Water tends to conduct electricity. So you need to stay away from water when there's a lightning strike. And tall trees. Okay? Tall trees. Lightning loves tall structures. Okay? So you don't want to find yourself trying to take shelter under a tree because it will barbecue you so bad. And the unfortunate result is that you may end up dead. You don't want that to happen. Okay, so you must avoid tall structures and water. Right, that includes all forms of water. You should avoid swimming, showering, bathing. Okay, all those things. Just no, that's not what I meant. By avoiding bathing, I'm not saying you shouldn't bath, but don't bath when there's lightning strike, okay? But we should bath. It's standard procedure, that one, it's non-negotiable, okay? Right, and you should also avoid appliances that conduct electricity because they will increase your risk of getting shocked by the lightning. And the sad thing about lightning is that it has a higher electricity wattage than your socket plugs. So you can survive an electric shock from your socket plugs at home, but the shock from the lightning, the strike from a lightning bolt is very severe. So take care of yourself. Okay. Now let's do more questions before we take off to summarize our lesson. So what force causes the buildup of electrically charged particles in a cloud? Number 2, what charge, positive or negative, builds up at the bottom of a cloud? By bottom of a cloud, we mean within the cloud itself, but at the bottom. Okay, just so there's clarity there. Because of time, we are going to do these questions together. Okay? So what force causes the buildup of electrically charged particles in a cloud? Remember we said it's friction. When the particles bump each other, they rub against each other, and some of them lose electrons, and then some of them retain their electrons. That's what? Friction. So what charge, positive or negative, builds up at the bottom of a cloud? It is the negative charge. Remember, the positive charge accumulates at the top of the cloud until there's enough electrostatic charge to be discharged. The charge has to go someplace, okay? Let's continue. Activity 2, we are doing it together because we are trying to save time to do our WhatsApp questions. So answer the questions based on the diagram. You have a diagram on the left, you have positive charges at the top of a cloud and negative charges at the bottom, and there's a tree which is positively charged and the ground which is positively charged. So what forces cause the formation of electrostatically charged particles? Show. Those forces, okay, we're going to answer the questions anyway. Question 2, explain the formation of positive and negative charges in the diagram. Question 3, name 2 possible consequences of the buildup of electrostatically charged particles as shown in the diagram. Question 4, write a paragraph in which you describe the formation of lightning from the time a cloud is formed to the time the lightning strikes. And lastly, list 2 safety precautions you should take to protect yourself against lightning. So let's answer these questions together. Okay. What force causes the formation of the electrostatically charged particles as shown? That is friction. Explain the formation of the positive and negative charges in the diagram. Okay. As the air, ice, and water particles move in the cloud, they collide. The collisions cause friction. The friction causes the movement of electrons. When the electrons are lost, the particles become positively charged. When electrons are gained, the particles become negatively charged. Okay, so this is the answer to that question. As the air, ice, and water particles move in the cloud, they collide. The collisions cause friction. The friction causes movement of electrons, and when we lose electrons, the particles become positively charged. When they gain electrons, they become negatively charged. Okay. Question 3. Name the two possible consequences of the buildup of electrostatically charged particles as shown in the diagram. The possible consequences of the buildup of charge in the cloud and the ground is lightning and thunder. Those are the two possible consequences. Because remember, the charge has to go someplace. It doesn't want to stay there. It wants to neutralize itself. Okay. Number 4, write a paragraph in which you describe the formation of lightning from the time a cloud is formed to the time the lightning strikes. As the air, ice, and water particles move in a cloud, they collide. The collisions cause friction. The friction causes the movement of electrons. And as the particles lose electrons, they become positively charged. And when they gain electrons, they become negatively charged. Right. So when the electrostatic charge becomes high enough, because there's an accumulation of positive charges and negative charges. So when there's a high enough electrostatic charge, guess what? It's going to be discharged in the form of a lightning strike. Right. Number 5, list 2 safety precautions you could take to protect yourself against lightning. Right. What can you do to protect yourself against lightning? You can install a lightning conductor. You can seek shelter in a car or a building. Staying away from water and tall objects and trees. Avoid swimming, showering, and bathing. Any two of these will be acceptable. Okay. Okay, we are not going to do these questions because we are running out of time and we need to summarize our lesson. An electrostatic force is a force that two electrostatically charged objects exert on each other over a distance. Electrostatic forces act in an electrostatic field. Electrostatic field exists around any charged object. Atoms are electronically neutral unless electrons are added or removed. The electrostatic charge of substances can be changed by rubbing two substances together. Potential energy is the energy that is stored in a system. And static electricity has potential energy because it can do work. Right. So lightning results as the differences in electric charge that accumulates over time within a cloud and the ground. And then the charge will try to neutralize itself by discharging either within the cloud or with the ground. Okay. So lightning is a giant spark of electricity. Now let's quickly take to your WhatsApp questions. Okay, let's see what's there. What do we call force from lightning? It's an electrostatic force. Okay, right. Okay, let's look at another one. Okay, this one sent a voice note. How can I find out what is the lightning? Lightning is an electrostatic discharge that occurs during a thunderstorm. Okay, let's see if we have another one. What is here? What forces causes the formation of electrostatically charged particles? There is friction. Okay. What else? If an object gains electrons, will it be positively or negatively charged? It's going to be negatively charged. Okay. Thank you for your question. Let's look at another one. Okay, I think I answered this one. What causes a lightning? Lightning is caused by the accumulation of charges in the cloud and the ground, where positive charges accumulate at the top of a cloud and negative charges accumulate at the bottom of the cloud. And then once there's enough charge that has been accumulated, it has to go someplace and it's released as a giant spark, which is called lightning. It can be released within a cloud itself, or it can be released between the cloud and the ground, or between the cloud and some unlucky person, which is the most unfortunate event that can happen. Okay, let's look at this one. What is to repel? To repel is to push away. Okay, Last one. Okay, was to repel. I've already answered that one. What force causes the formation of electrostatically charged particles? We've already answered this one as well. That is friction. Thank you so much for your questions, and let's go back to our lesson. Okay. Right. So, when you finish this lesson, what I need you to do is you need to, at the bottom of your screen, there's a complete and continue button. Please press on that, and then you will get bonus points for finishing the lesson. But what I need you to do from here is, I need you to stay tuned next week, same time, because we are going to have another live lesson where we are going to start looking at electricity, okay? We are going to look at uses of resistors. I think that's going to be very interesting because we are going to look at things that we use almost every day, actually every day, because resistors are everywhere. We use them at home, we use them at work, we use them at school, and we are going to learn how they work and why we use certain resistors, okay? So that's going to be a very interesting one. So what I need you to do from here is I need you to go through what we've learned, and hopefully you learned something from what we discussed today about lightning and electrostatic forces. Right, and that brings us to the end of our lesson. So please remember to take care of yourself, wear your mask, keep your distance, and sanitize your hands regularly, and keep safe until we meet again for our next lesson, where we are going to be looking at uses of resistors. Thank you so much. My name is Kwanele Dlamini, and it's been a pleasure hosting you for this lesson for natural sciences, and I hope you learned something from it. Until next time, remember this lesson was proudly brought to you by the Gauteng Department of Education.